So basically for the aerobic performer, so this one's the aerobic performer and then this one's basically before training. So in aerobic exercise you basically want to be running for a longer distance. So here we can see that he stops at around 17, at a running speed of 17, whereas with after training the aerobic performer could possibly go on for even longer. Also for the aerobic performer after exercise, you can see that he's consuming a lot less oxygen compared to the first the first try before exercise. This is because of the demand in the muscles for oxygen. So basically, the aerobic performer after exercise does not require as much oxygen after exercise in the muscles, whereas before exercise there is a higher demand for oxygen in the muscles. Right, so now we're moving on to the respiratory muscle strength. So basically, after exercise our respiratory muscles are changing. So our muscles get fitter and they get a lot stronger, therefore meaning they can contract harder and they can go on for longer periods as well. So this basically leads to an increase in oxygen consumption, meaning that there's a higher intake of oxygen and there's more oxygen being diffused into the muscles, so that our muscles can work more efficiently and they can work harder and better. So muscles are more efficient, as I just said, and the oxygen diffusion rate. So this basically means that the oxygen being diffused into the muscles from the blood is basically happening a lot quicker, and it's basically a better response, and it's basically a much sharper contraction as well. So the whole diffusion rate is increased, therefore the muscles can work a lot quicker and a lot harder. Right, so now moving on to lung volumes then. So as we are basically inhaling a lot of oxygen now, we're inhaling a lot of air, most of our lung volumes are actually increasing because our lungs are basically increasing in size, therefore resulting in more oxygen being inhaled. So TLC and vital capacity therefore increase as our lungs are basically making more space for oxygen to be inhaled. Our residual lung volume is however decreased, basically due to the massive space that our lungs are creating. Our tidal volume is increasing and our pulmonary ventilation is also increasing. Right, so now moving on to capillarization. So capillarization is basically where there's more capillaries being formed, making diffusion a lot quicker, making it a lot quicker process. So in submaximal and in rest, capillarization, this basically stays the same, so there isn't much change. However, in maximal exercise there is a change, there is a massive difference, there's more capillaries being formed, therefore it results in more diffusion taking place, more oxygen being diffused into the muscles. So therefore there's an increase in pulmonary diffusion, so therefore this means basically that there's more circulation of blood around our body, more oxygen being transported to our muscles and throughout all of our body. Also ventilation increases as well, so as there's a lot of diffusion to the muscles, there's also a lot of diffusion back into the blood. There's a lot of diffusion from the muscles producing CO2 back into the blood for it then to be exhaled, so therefore there's a lot of ventilation, breathing in and breathing out. Also, as there's a lot of diffusion taking place and there's a lot of oxygen being consumed, this therefore results in alveoli increasing in size and holding more oxygen. So now moving on to our neuromuscular system then. So basically with our neuromuscular system, our glycogen and triglycerides stores basically increase. Also our MB and mitochondria, they increase in size. Our fast glycolytic muscle hypertrophy then. So this basically means that our fast glycolytic muscle fibers are basically increasing in size and they have a better effect. So the proportion of muscle to fat, and this so basically after we've exercised, this basically means our muscles are increasing in size. This results in our muscles having a better proportion to fat. So there's more muscles than there are fat. And then the triglycerides, they basically are the leading form of what basically carries fat around our body. So they basically increase in stores, the same with glycogen, which is a store for energy. So there's more energy being stored and there's more energy being used. So basically the mass of the fast twitch fibres then, so the mass of it is actually increasing as well, making the contractions a lot quicker and there's a lot more force involved. However, this then leads to, so the more, basically the stronger the stronger the muscle fibres are getting, this basically can lead to hyperplasia, which is basically the enlargement of a cell. This can often lead to cancer as well, so this can be a good thing when the muscles are increasing in size, but however, the enlargement of a cell can often lead to cancer, which is a definite bad thing. And then we have mesomorphy, which is basically your muscles are increasing a certain size, basically leading leading yourself into looking like a mesomorph. Right, so now we have neurocontrol and Inition. So what is this basically? So basically, we're talking about the response to the CNS through motor units and loads of other things. So basically, our proprioceptors are increasing in size, and they're basically being more responsive to different situations, to different stimuli. So this therefore results in the response back to the CNS being very quick, which then leads to us having a lot more motor units. So us having a lot more motor units basically results in us being able to give a lot of feedback back to the CNS so that it can control the feedback and then give feedback to the muscles so that we can change after exercise and during exercise. So as there's a lot of feedback being given and a lot of feedback being given back, this therefore results in our coordination being a lot better. This is because we can use our leg muscles, our arm muscles, any muscles around our body more efficiently as we can react to different situations a lot quicker. So this is all mainly because of the more responsive proprioceptors after exercise. Right, so now moving on to energy systems then. So we have our aerobic and we have our anaerobic energy system. So our aerobic system then. So basically after exercise there is a better oxygen delivery and there's a better consumption as well. This is obviously because of the demand in the muscles. So there's more oxygen being inhaled and there's more diffusion taking place in our capillaries to our muscles, so there's more oxygen being diffused. We also use a lot more glycogen, which is basically a store of energy. So this basically means that we're using a lot more energy in our exercise sessions, which basically results in our muscles working a lot harder and working a lot quicker as well. There's also a lot more FFA transformed into energy, so it's being broken down and it's being transformed into energy as well, like glycogen is being used for energy as well. So there's a lot more energy being used. And then our anaerobic system, so we have a higher ATP and PC stores. So basically this means that we have a lot more use for them, we have a lot more ATP and PC to use, so that we can basically use them for energy in short duration events such as 100 meters for example and 200 meters, so basically short sprinting events. And we also then have basically a higher lactic acid tolerance. This basically means that we are tolerant to the lactic acid buildup. So during exercise we obviously have a higher, our lactic acid basically increases, so therefore after exercise our lactic acid tolerance increases, so we don't suffer from the same sort of things lactic acid could make us suffer from. We also have a delay for OBLA, which basically means that we can work for longer periods using our anaerobic system before we have to go through the recovery stage of OBLA. Right, so now we have the skeletal adaptations in. So basically, as our muscles are increasing in size and in mass, and in strength as well, this basically results in our bones and basically increasing and becoming a lot stronger. So after exercise, our calcium stores are basically increasing. This then results in the thickening of the muscle, not the muscle, sorry, the bone. So the bone basically increases in density. So the bone density increases. That means it gets a lot stronger. We also then have a cartilage thickening and synovial fluid. So basically, this is where the basically the overall stretch of the tendons is basically increasing, so we can stretch for a longer distance. And not only that, the connection between our tissues is also a lot stronger. The same with the connection between joints is a lot stronger as well, so that we don't suffer from as much injuries as we could do during exercise. So it's basically, after exercise, the strength of our bones, the strength of our joints, and the connective tissues and the synovial fluid, they're basically increasing in strength, and they're being a lot more supportive after exercise than what they were doing before exercise. Thank you for listening.